All right, team. Welcome to the first of the videos in my nuclear decay video question series. This one is going to be about writing nuclear decay equations. So we covered these in lesson 5. This is in the same lesson that we learned to balance nuclear decay equations in. This is specifically questions 13, 15, and 17 in the 2025 version of this packet. That being said, if you're watching this in the future, first of all, hi from the past. And second of all, it may not be those numbers anymore. However, we're still going to balance them the same way, even in the future. So, as a reminder, these are going to follow the same pattern every time. So we have our reactant becoming product plus the decay form. Okay. So, to do these, you are going to need a periodic table. If you don't have a periodic table on you, pause the video now and go grab one. And then we'll get started in just a sec. All right. So in our first question here, we have carbon 14. So what particle is produced when that carbon 14 undergoes beta minus decay? This is a great question. Let's find out. We know from the question what the reactant is going to be. Our reactant is going to be C14. We know that in isotope form, we name the element, and then we put the number, and that number is the mass. Okay, that's our format. So we have the name dash the mass number. Let me switch over to a pen because I don't think you can see that very well. So I know that carbon 14 has a mass of 14, so I'm going to put that on the top. C is the symbol, but I don't know how many protons I have. I don't know my atomic number. So to figure that out, I'm going to look on my periodic table. Carbon is over here on the right-hand side. It's in column 14. When I look at carbon, it has two numbers. It's got 12.01 and 6. We know that we can't have 0.01 of a proton, so that one's not going to make any sense. We also know that the atomic number is always in the top part of the periodic table, so the atomic number on carbon is 6. When I switch back over to my question, I'm going to put 6 on the bottom. And I've now written carbon 14 as an isotope. From here, this is going to undergo beta minus decay. So I'm actually going to draw right on my little particles right here. Alpha is this one. Beta. Is that beta plus or minus? Plus. And minus. Make sure you got the tail on there, otherwise you have boron. So, to undergo beta minus decay, I'm going to be looking at this one. I'm going to have an electron involved, not a positron. That electron is not in the reactants. Remember, it's part of the product. So I'm going to draw my arrow to show that there is a change. And then I'm going to include my beta minus decay. You can include this either as that beta with a minus sign or in this notation. Either would be considered acceptable. Because I'm going to have to do a little math, I am going to use the numbers 0, negative 1. I'm going to put my E for my electron. Okay. So this is the setup for the question. It gives us carbon 14, which we knew is our reactant. It undergoes beta minus decay, which is this symbol right here. Just realize you can't see me moving my clicker, which is this symbol right here. And then we're going to add to it that product. Remember, addition can go in any order. Add in something. I also know that across the top, all of my masses need to stay the same. And across the bottom, all of my proton numbers need to stay the same. So using that knowledge, I'm going to look on the left-hand side of my equation. I see that my mass numbers have to total up to be 14. Some number plus 0 has to equal me to 14. So 14 minus 0 equals 14. I also know that across the bottom, 6 is equal to -1 plus some number. Be very, very careful here. What I see a lot of students do is they'll do 6 minus 1 and it equals to 5. 5 minus 1 does not equal to 6. Okay, this is going to be 7. 6, 7. So 7 minus 1, or I guess plus -1, but 7 minus 1 here is equal to 6. To figure out what particle this is, I'm going to use my periodic table again. I look for atomic number 7, and I'm going to find it right here next to atomic number 6. Remember, this is in number order, left to right, top to bottom. That isotope is nitrogen 14. So to show that I have nitrogen 14 here, I'm just going to add a capital N, the symbol. And if I wanted to write it out, I could. This is nitrogen. I put a dash to show it's connected, and then the number 14 to show the mass. Okay, it's not -14, it's not -14. Those are also things I've had kids ask me in the past. I don't know what just happened with my light. But part of what we're looking at now, nitrogen 14. I'm going to pause the video really quickly on my end just to see if I can get the lighting to come back. Okay, I don't know what I did to break the lighting, but I broke the lighting. That's okay. We can still solve question number 2 even with this kind of bluish tint to the lighting. So number 2 is going to ask us to follow the same set of steps. What particle is produced when magnesium-23 undergoes beta positive decay? So I'm going to start the same way I just started. I know from the question that magnesium is Mg. And that is atomic number, I'm sorry, not atomic number. The atomic mass is 23. I also know from this question that we're undergoing beta plus decay. So I'm going to draw my arrow. And then I'm going to represent beta positive. So if I need a hint, I can always look up here. Beta plus is 0 plus 1e. That is a positron. I'm going to write that in. I like to put the plus on my one. You do not have to. You do if it's negative, but for the positive, you don't. I also know that this is going to produce some other particle. So I'm going to put the plus in and just wait for a second to fill it in. So everything that is written in black right now was given to us by the question. It tells us right in the question that we know all of the stuff in black. The next thing we have to do is figure out some stuff in blue. Stuff in blue is going to be stuff I find on the periodic table. So here's how I do it. I know I'm looking for Mg on the periodic table. When I look at the periodic table, my hint for you, again, this is in numerical order. The more protons it has, the more mass it's going to have. So 23 should be pretty close to the top. When I start looking around, I find that Mg is magnesium. Magnesium is atomic number 12. So on my little paper, I'm going to write 12 under 23. And I'm going to do mine in this like lightish blue color, just so that it stands out a little bit, that this is different. Okay. So that 12 comes from the periodic table. That was not given to me in the question. I had to find that on my own. From here, I'm able to do a little bit of math. So I know that 12, remember this arrow is equals to, 12 is equal to 1 plus blank. So in my blank, I know I have to have something that when I add it to 1 is going to give me 12. That's going to be 11. Across the top, 23 is equal to 0 plus something. That one should be pretty easy. That one's 23. So the last thing I have to do, I'm going to use 23 over 11 to help me figure out what the heck this is. So I'm going to look on my periodic table again, and I find that 11 is sodium, Na. Sodium is one of those weird ones where the symbol and the word don't quite line up, but that's all right. We can still do math with it. So I'm going to write Na. And then to write that out, you're going to write sodium. Then put the dash, and then the mass number, 23. For our last one, we're actually not looking at beta decay at all. If you remember me saying this, / it's written on your cheat sheet, beta only changes the bottom number. Now, you guys might have noticed that these isotopes all have the same mass value as what they started with. We're going to do a practice question now that involves alpha decay, and that's not going to be the case anymore. So for alpha decay, we're looking at U238. Take a second, pause the video, and see, can you write U238 as an isotope? Go ahead, pause now. So, welcome back. I've got U written out already. That's our symbol for uranium. We also know 238 is the mass number, so that's going to go on the top. Then I've got my arrow, because I know that my format's going to stay the same, right? Reactant turns into product plus decay. I don't know what the product is yet, but I do know that the decay is alpha decay, which is that helium-4 isotope. So I'm going to write that. And again, you can always write this in the Greek if that's more helpful for you, but I find that most kids like to have the numbers. Okay. So I have uranium turns into 4-2He. This is where I'm going to use the periodic table to help me. Some of us, because we've used uranium literally every lesson this unit, might even know off the top of our heads that uranium is going to be in the bottom. It's an actinide series is what we call it. So actinium is the leader of the actinide group. We find uranium down there. It's number 92. So I got to switch my color. So I'm going to write 92 in for uranium. From here, I know I have to set these equal to, and this one there is going to be a little math going on. Okay. So across the bottom, 92 is equal to 2 plus blank, plus something, right? So I'm going to give you a second to try to figure out what those numbers would be over here first. Keep in mind, it's this number plus blank. 4 plus blank equals 238. Ready? Go ahead, pause now. Welcome back. Across the bottom here, 92 is equal to 2 plus 90. Across the top, 238 is equal to 4 plus 234. So to figure out what element this actually is, I'm going to look on the periodic table for number 90. I find it down here as TH, that's thorium. You might remember thorium from the day we played with the Geiger counter. So this is TH. To write it out, it is thorium. Then the dash, then 234. Folks, I hope this video helped you to kind of understand a little bit more about how to do these. As a reminder, there are help slides on how to do these on Google Classroom that will continue to walk you through step by step for 3 more questions. Best of luck to you. Bye-bye.